Hello everyone, and welcome to your video on ratios and proportions. So the first question that you likely have is, what is a ratio? Well, a ratio is just a mathematical relationship between things. See that scribble? I used to say that it was a mathematical relationship between two things, but that is not true because ratios can be used to show the relationship between many things. It's up to you. However, many ratios that we will encounter show a relationship between two things. So here's our first example, and I have for you an assortment of dots. I have red dots and I have blue dots. So let's say that I wanted to set up a ratio of red dots to blue dots. Okay, how would I go about doing that? Well, I would count how many red dots we have. 1, 2, 3, 4, 5, 6. So I have 6 red dots, 2, which I write as a colon. How many blue dots? 1, 2. 2 blue dots. And this is one very common way to write ratios. The red dots, a colon, and then the blue dots. I think this looks cool. However, there is another way to write ratios which might prove to be a little bit more useful to you, and that is that you can write it as if it were a fraction. So we could say 6 red dots over 2 blue dots, okay? 6 over 2. Now, you know that 6 divided by 2 equals 3, which is not clear exactly how that relates to this. So I don't want you to think of it as now you divide it and it equals 3. I want you to think of it as 6 red dots compared to 2 blue dots. Now notice that you get a completely different thing if I ask you about the ratio of blue dots to red dots. In this case, we would list our blue dots first, which is 2, to red dots, which is 6. Or if you were writing it in fraction form, it would be 2 over 6. Okay, so notice that order matters. So when you're reading your problems, you want to make sure that you're paying attention to which item is supposed to be coming first. In this case, red dots and then blue dots. In this case, blue dots and then red dots. Now, one of the advantages of setting your ratios up in fractional form like that is that it makes it much easier to compare. So for instance, let's say that I gave you these two fractions. I gave you 3 to 2 and I gave you 5 to 4. And I said, which fraction is larger? Which one is larger? Well, the way that you would solve that is you would set each ratio up in fractional form, 3 over 2, and you would actually divide that and get 1.5. And here you would do 5 over 4, and you would divide that and you would get 1.25. That means that this is a larger fraction. Why? Because 1.5 is bigger than 1.25. That's why. Okay, so it can be very helpful to set it up in fractional form like this. Okay, now your next question is, what is a proportion? Proportion. And that is two ratios set equal to each other. For instance, if we go back to our blue dots and red dots, I could say that 6 red dots to 2 blue dots is the same thing as 3 red dots to 1 blue dot, right? Because these are equal to each other. I can reduce 6 over 2, I can reduce it to 3 over 1. All right, that is not very exciting. The way that proportions get exciting is when you start solving for unknowns. So let's do an example. So here we have some information about Marlborough College in Vermont. It has a student-faculty ratio of 5 to 1. 5 to 1. And it has about 170 students. How many faculty are here? Well, let's set up our proportion. So here we have student to faculty. So I'm going to put student over faculty. So this is student and this is faculty. You don't really need that S and the F, but I'm putting it there just so that we set up our other equation, our other fraction properly. So we have about 170 students. Is that 170 students going to go in the numerator or the denominator? It's going to go in the numerator. Why? Because I said that I was going to put students in the numerator, and I need to be consistent from one fraction to the next. And then X is what we're trying to solve for. It's how many faculty are there altogether. Now, whenever you have two fractions set equal to each other, you can cross multiply, which is just a wonderful thing. So that would give us 5 times x, or 5x, equals 1 times 70, 170, which gives us 170. Divide both sides by 5, x equals 34. So this particular college has 34 faculty members. That is what we're able to calculate because we set up this proportion. Great, let's do another example. So here, another true story, Starbucks. Starbucks is being sued because an iced beverage advertised at 24 ounces contains only about 14 ounces of fluid. How many ounces of iced coffee would you have to order in order to get a full 100 ounces of fluid? Well, again, we're going to set up a proportion. So I could say 24 ounces, which is advertised, compared to 14 ounces of fluid, equals how many would I have to buy of advertised in order to get 100 ounces of fluid? Okay, so that's a good proportion to set up. However, it is not the only proportion that you could set up. You could do it the opposite way. You could say there's 14 ounces of fluid for every 24 ounces advertised. And that means that if I want 100 ounces of fluid, I need X number of advertised ounces. Notice that these are just flipped. It doesn't matter as long as you're consistent. Advertised to advertised, fluid to fluid. Fluid to fluid, advertised to advertised. Either way, you're going to get the same answer. So let's do this one because that one is the last one I wrote. So I get 14x equals 24 times 100 is 2400. Divide both sides by 14. I get x equals about 171. About 171. So I would have to order 171 and a little in order to get 100 fluid ounces. So 172 might be the best answer if I'm given only, if these are my test options, 172 is going to be the best because 171 is not going to give me the full 100 ounces. I would need to order 172 ounces in order to get a full 100 ounces. Okay, so that is Starbucks. Now we have one more to do. And this is from the World Health Organization. The World Health Organization reports that for every 27.1 cases of measles worldwide, there are 241.3 cases of malaria. So if there are 5 cases of measles in your town, how many people are expected to have malaria? Okay, so I'm going to set up measles to malaria. And I'm going to have that equal to the 5 measles, because I'm keeping my measles on top, how many people are going to have malaria. Okay, so I'm going to do cross multiplication. So I get 27.1x equals, this is going to be 5 times 241.3 times 5 equals 1206.5. Divide both sides by 27.1. X equals 44.52, blah, 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 blah. So I would expect 45 people to have malaria. Now, this provides us with a wonderful example of how people misuse mathematical concepts. Because if there are 5 people who have measles in your town, do you really think that there are 45 people who have malaria in your town? I sincerely hope that your answer to that question is no, I do not believe that. Because we know that there are extenuating circumstances here, right? Like, for instance, malaria, not very common in the United States. Really not very common in the state of Minnesota. So it would be incorrect for us to say that simply because this is true worldwide, it's also going to hold true in our little town. No, that cannot, you cannot make that leap. So this is an important reminder that even when you're doing math and you get a correct mathematical answer, you still need to run it through that old common sense factory in your head and make sure that what you're saying actually makes real sense. Because math just makes mathematical sense. Okay, that's it for ratios and proportions.